Good evening, and thank you all for joining us today. My name is Rashmita, and I'm the event planner for Microsoft Reactor Bengaluru, India. This session will run over the next 60 minutes, including Q&A. The session is being recorded and will be uploaded to our Reactor YouTube channel. I will share the link to our YouTube channel in the chat section soon. Before we begin, please take a moment to read our code of conduct. We are all here to learn together, so please be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat will be open throughout, and we do encourage you all to participate. Also, please keep your mics muted during the session. I would now like to welcome Shivam, our speaker for today's session. Shivam is an author, cloud architect, speaker, and co-founder at TechScalable. He's passionate about technology and works on Azure, GCP, machine learning, and blockchain. He is also a Microsoft certified trainer. But for now, I will hand over to Shivam to begin the session. Over to you, Shivam.
Thank you, Rashmita. I will share my screen. Okay, so welcome everyone. Hopefully, all of you are safe. And check this out. Let me walk you through the agenda for the day, and we will understand the problem statement which we are trying to solve, and we will talk about the real-time inferencing of machine learning models. So the very first thing I want to show you is that if you go to the meetup page, you will find that we have put the further learning link over there. It's also in the chat window right now. You can take it up from there as well. So if I go to that page, it takes me to MS Learn, where we have the after session tutorial or after session self-learning link over there. So whatever we will discuss is available on this page as well in a more structured manner. So you will see that we are going to talk about how to deploy the real-time inferencing web service. We'll talk about the background of it. We'll talk about the various concepts you should be aware when you are deploying it. And if you just open these links over here, I'll just show it to you. So after the session, you can go and you can do these exercises and you can read these tutorials as well. So the first one talks about that what is a real-time service and where do we deploy it? What are the various locations where we can deploy that? Then we talk about how do you, the practical process of deploying it, like step one, step two, step three as such. So you will see that the registration of the models are here. How do you do the inferencing over there? We'll talk about this, what is the entry script and so on and so forth. But just to show you that everything which we'll be covering is also available on this page in a very structured manner, how to deploy the model. Then you can go next and you can see how to consume the real-time deployed model as well over the REST API endpoint and how will you do the authentication authorization. So authentication will be done. There is the authentication over here. There is no authorization in this example, but authentication will be done either by the key or the token over there. So how do we get the token, from where do we get the key as such, and how do you troubleshoot it? Whether troubleshooting when things go wrong, then what are the known troubleshooting steps as such, and where to get the logs from, where the logs are available, how can you deploy it locally first, test it out, and then deploy it in the cloud after that. So that part is here, and then the exercise after that. So whatever I will show you is also available on this page. You can go to this link, and on that page you will find the entire list of Microsoft. I'll just show it to you. So Microsoft is having like we do custom machine learning, right? So this is the entire tutorial list from Microsoft. And the one which we are focusing on right now is this one, the real-time inferencing one, that one. And we'll go through a couple of other links over there, but that's the one for today's topic over there. So everything is available on GitHub. You can do your self-learning and you can go through this, right? Now I'll just take you back to the whiteboard and I will explain what we are doing first. And then once we have understood what we are doing, we will practically go and check the code. So today the session is more code oriented, right? So we have we don't have much of you can say visuals and so on and so forth. So let's get started. Now, before I take you to the whiteboard, just want to show you that I have deployed one machine learning service in the Azure cloud. This is my demo Azure subscription, and I will zoom in for you. So in this subscription, I have basically deployed one machine learning service here, which is Microsoft's custom AI solution. And apart from that, one container registry is also deployed over here, that one. Kubernetes service got deployed on the way. I didn't do it. I'll show you how it got deployed. We deploy in the starting. I had a key vault, storage account, and application insights for monitoring purpose. So the bottom three, four solutions were there, and the container registry to start with. And then this is the machine learning service. So if I expand it, this is how it looks like. If you launch it, this is how it looks like. That's how the Azure custom machine learning solution looks like, machine learning service over here. And it is having all these options on the left hand side. So we will go through the code very soon. So let's understand a little bit about what are the prerequisite for the model training, and how do you practically work with it, and then how do you deploy it, and what are endpoints, what are the new endpoints, the ones which are newly provided, the managed endpoints, and what were the old ones, the web service one, and how do we differentiate between them, and the new ones are in preview. So and the old ones are the ones which we are already using. So just to show you what I have on this page over here, I'll just take you back to my whiteboard. So basically, now I'll brief you about the service in next 2 to 5 minutes, and then will hit with the code over there, right? Now, the very first thing is we have data stores. Data stores are the ones where the data is kept. So these data stores are Azure services, which we are registering, and these services are getting registered in the Azure Machine Learning, you can say service workspace. So the data scientist do not need to worry about the various endpoints and connection strings and service endpoints and all the details about how the connectivity is being created. So we can have various type of data stores in Azure. We can have the object storage. So the object storage is very good for storing unstructured data. It stores any file format as such, but it is very good for storing unstructured data if you're working with images and so on and so forth. If you're working with structured data, you can go for Azure SQL as well. So you will have tables over there. We can get the data from these locations. So this is available on the in this section over here, data stores. You see, these are some default data stores. So you can add the data stores from that section. So what other locations can be there? We have the replacement of HDFS data lake as well. Data lake Gen 2 in Azure ADLS, Azure Data Lake Storage. That can also be one of the data store where you are getting your data from, or Postgres, or you can get your data from MySQL and other locations as well. There is no limit. It's just a few of the options which we are trying to understand. So data stores are the locations where the data might be, the data literally is kept as such. Now on top of the data store, or it's not that it's mandatory that data store should be there, but we have another concept called as data set. So data sets are is metadata. Data set doesn't have any data, right? In data store, literally you can say in the storage account, data will be kept. In the blob storage here, you will have the files will be there. In this data lake, you will have your Parquet files, you will have your images and so on and so forth, CSV, TSV, Evro, JSON, anything which you want to work with, things will be there. But in the data set, these are metadata only. It's just metadata. It just represent like the file format, the is the first row header or not, is the if you're reading from maybe a database, then which table are you reading from, and so on and so forth. So we have two type of data sets in Azure Machine Learning Service. One is called as tabular data set. Now tabular data set is the one which we find. So if your data, if you want to load your data in a pandas data frame finally, then the one which you should have created is tabular data set. So it will just have the schema there. It will not have any data. So this, don't get confused by this table. It won't be having any data, only schema. So it will just point to the data. It will hold some metadata. Now, the second one is called as file data set. When we work with multiple files or when we work with a lot of images, right? And so in that scenario, you have to specify the file path. So imagine in this data lake, we have one container here like this. Not the Docker container. You can imagine HDFS container. So you have to specify the file path. So you will say that, okay, I'm going to read the data from that file path. And on that file path, recursively, we will load all the data. So file dataset represent the file path where multiple files are there, which we want to recursively read later on. Tabular dataset represent the data which we want to load in you can say pandas data frame. So it's like a table. Think of one file in tabular manner. Okay, so when it comes to, so this is about the data set. Now, how do you train it? How do you do where do you write the code, right? So we can use Visual Studios. We can use Visual Studio Code as well. We generally use Visual Studio Code as such, the free one. And in the cloud, there is one development environment which is provided called as compute instance. So if I take you back, if I click on the compute, you will find we have compute instance here. You see this? If I click on the Jupyter option, it will open that in the browser. So the machine is in the cloud. I don't have to use my laptop right now for the development purpose. This is in the cloud right now, right? The Jupyter notebook is there. We have other options as well: Jupyter Lab, VS Code, RStudio, Terminal, and Notebook. Notebook are these notebooks over here, which is you can say little more. You can say, let's click on one of them. You see this? The 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 code is opening, or the notebook is opening in the UI itself over there. So this is the notebook section. So the compute instances are the ones where we are doing the model. We are developing the model. So here you will install your. So this is your development environment, and you can also do some local model testing here as well. But the compute clusters are available. These compute clusters are the ones where we do the model training. So we have CPU based compute clusters. We also have GPU based compute cluster. So you can go for your suitable size of compute cluster. You can even go for distributed machine learning over there, or deep learning over there with any type of TensorFlow distributed, or maybe Horovod as such, or any other library which you want to go for in terms of parallel deep learning. Now, once the model has been trained, okay, so now the background is done. So finally, so the development will be done using the compute instance, or maybe use your laptop, just submit in the cloud, doesn't matter. But finally, the models which are trained, right? So for example, I'll zoom in for you first. You see these models which are trained. I'll show you how I have trained these models as well. But you see these versions, the same model has multiple versions right now over here. There's a different model over there. It is having version 1 over there. So if I take you back to the whiteboard, so when you will do the model training, you one of the requirements for of any machine learning project will be to save your model in a model registry. So the model registry is available inside the machine learning service itself, and you will be able to register your model. So how do we do that? Right? If I just take you back to my notebooks, and we'll just quickly see the code, how to do that. We will be training the models over here. So you will notice that, and anything which I'm showing, all of this is available uh, in that learn module which I have given over here. Okay, so we are training one machine learning model, and if you notice over here, so we are registering the trained machine learning model after that. So for the registration purpose, we basically specify like run.register. Run is the current run, the run which has executed just now in the previous step, and the and it can be a local run, it can be the compute target run as well, where it got trained on the in the compute cluster. So after that, we are registering the machine learning model. So this is also possible like this, right? The model can be anywhere. You can also manually upload it. Let's say you trained it yourself and you want to upload the model, you want to save it, you can do that as well. You just need to have the pickle file or any saved file format. ONX is also fine. You need to have the saved model with you. So if we do it in the flow itself, you will notice that we are specifying the model or register, and we are specifying the name of the you can see the model path, and we are specifying that the name of the model will be this model. It is available on that location. Save it at as that. and specify the accuracy and so on and so forth. So when we run this particular line, this happens. The model get registered over here with the version, and if I click on it, it will show you the entire tags over there. That the script was parameterized and the script was created on some particular time. It had some particular version, diabetic model, custom type, so some run ID is there for that purpose. Now, the once the model has been registered, check out the interesting part now. So to be able to deploy the model, there are a couple of things which are required, minimum requirements. So the very first thing is obviously the model, right? So you need to have the trained model. So the trained model which is registered over here, that's one of the things as such. See, like that. The second thing which you require is an entry script. Entry script is also called a scoring script. So entry script is the one which will be finally deployed in the deployment location. So if I just show you what I mean by that is, so let's say your model got deployed in production. So you see this file which I have over here, the score script, score.py or the entry file. This is the file which is supposed to be there. Without that, the model will not be deployed. What it does is when the data comes over the API call, this particular script, it basically loads the model into RAM. That's one thing. Loads the model into memory, and then whatever data comes over the API call, it does model.predict over there, and then the output goes back. So the Y dash will be going back. So one of the most important thing for the model to be deployed is the entry script or the scores p.py file. These words are very commonly used. So if I number them, we need the trained model. One, we also need the entry script. And the third thing we require is the environment. Now the environment can be a Docker file, meaning the with the Docker file, the image will be created, or you can also have you can provide the YAML file itself. Or you can provide the image itself. So let's say the Docker file is there as part of the environment, or maybe the image itself. So, and the image is already pre-created and it is stored somewhere, and that's the Docker image. And this Docker image is having all the things pre-installed. So, but we require the environment. So finally, when we have the environment, finally, when we have so what is the purpose of Docker file? Docker file is used to create the Docker image. It contains the instructions how the Docker image needs to be created. So we need these three things minimum to be able to create the image which will be finally deployed. So what is the meaning of image? Image is this Docker image which we are creating over here. You see this one, like this. So we have the trained model. Now, let's say version one of it or version two of it, whatever, whichever version you finally have, you went for. And then after that, we have the entry script, which is this box which I'm coloring right now, and the dependencies. Those circles represent the dependency. Now, another very important component of any MLOps pipeline or of production operationalization of the ML model will be the registry where you will save your images. So your CI pipelines will create the artifacts. So in your MLOps pipelines, you will have the artifact. So this can be the artifact over here, the final image as such. So this artifact will be stored somewhere. That storage location is called as Azure Container Registry. So it's a repository for images. So we store the images over there. So if I show you the repository which I have created, that's my repository over here. This one, Container Registry, ACR, this one. So if I click on it, and if I go to the repositories over there, you will find the model, which the image of the model which I have finally deployed. But this is the image of it, like the one which finally got deployed. So like this, like one to latest and so on and so forth. So this represent the image. So what is this? This is this part. The image which is having the ML model. It is having a tag. It is having the dependency and the entry script. So now we are ready for deployment. So when we talk about deployment, right? So imagine you want to deploy this. So now there are many deployment targets in Azure. There are a couple of targets which we are concerned about right now. One of them will be Kubernetes and one of them will be Azure Container Instances. So before I go there, I just want to bring you to what is an endpoint and what's the meaning of deployment. Let's go through these concepts first, right? And then I'll show you how to do the deployment as well. So basically, These two things are there. They are related to each other, or you can say they have a relationship between them, like they depend on each other. Uh, in a sense that the endpoint, I think I have a diagram here. I'll just use that. You see this? So endpoint. So this endpoint is the REST endpoint, is the HTTPS endpoint where the API call will come like that. So that is representing the endpoint. And deployments are the resources where which will do the inferencing for us, like where the model will be there, or any other resource which is required for the inferencing will be called as the deployment. Now, one endpoint can have more than one deployment. So typical deployment mechanism which we use is the blue-green deployment. Like if you create the new machine learning model, then you will create the new one is called as the green model over here, or the green deployment in this one, blue-green deployment, the green part, and the old one is the blue one. So slowly we will change the traffic. Like let's say 90% traffic is going to the old machine learning model, the one which may not be performing that well, and you have just retrained the new ML model, so which is right now having 10%. So after some time you can increase that. You will have let's say 80-20, 50-50. Then one day you will remove the blue machine learning model, and you will also keep it for some time in case we need to do a rollback. So the blue one, the old one, will be available in the staging environment for the rollback purpose if something goes wrong with the green one. But in this sense, so this endpoint which you see, that endpoint is available in the portal over here. So if I take you to the Azure portal, you see this endpoints here like that. So these are representing the endpoints. I have two endpoints right now: my service endpoint, my diabetic service endpoint. One is Kubernetes based, one is container instances based. Over there are two endpoints right now in this example. So this endpoint is representing that REST endpoint over there. And the deployment at the backend, you see this deployment has been done in AKS, Azure Kubernetes Services, and the other one has been done in Azure Container Instances. Now, Azure Container Instances do not scale the way the Azure Kubernetes Services instances, or you can say Azure Kubernetes Service based services scale. We use this ACI for the purpose of dev and test. We avoid it using in production because it doesn't have that capability of auto scaling when required. So the purpose will be for dev and test purpose, right? Now, so uh, the okay, so what is Kubernetes? Kubernetes is the one where it's your container orchestrator. And here you can specify when you're deploying a machine learning model over there, you can specify the auto scaling functionalities as well. So I'll show you what I have done over here. So if I take you to my notebook, and if I show you the one where I have deployed it in those instances. So the steps are not really very different, but I will just show you the main part first. Then I'll show you the supporting code over there. So check this out. So we are deploying in the AKS target, and the target is called as my AKS cluster. So before this step, I went one page back and I clicked on the compute and I clicked on the inference cluster and I created my AKS cluster there just before that. And when I created that, this AKS cluster created one cluster. It can be existing, it can be new. So this is a new one which I created. I didn't had it existing I didn't have it in that point in time. And this is the Kubernetes cluster which got created because of that step. So once the Kubernetes cluster was there, then after that, you have to go back and you basically have to deploy it over there. So we are saying AKS Web Service deploy. So the beauty of this product is, or the SDK is that the complexity of writing a YAML file, if you know how to work with Kubernetes, or the complexity of writing, of knowing the that from or of knowing further details about Kubernetes. There is a high learning curve when we talk about Kubernetes. That is abstracted from the data scientist. Data scientist or the engineer is abstracted. They're not supposed to, you can say, they anyways have such a big learning curve, right? When you work in data science, you anyways you're learning a lot. So this is abstracted from them. So you will see that it can be deployed in this manner. We can have AKS Web Service deploy, and the deployment can be right now we are doing it manually. This can be done with your CD pipeline as well as part of MLOps. And you can see one CPU core, one GB memory, and auto scale. I have enabled the auto scale over there, and the utilization will be in 30. So target utilization. So if the utilization of the resources goes beyond 30%, then scale out. So minimum replica 1, maximum 3 right now. It's in my example over there. So right over here. So when we do this model.deploy, basically the model gets deployed inside Kubernetes. So if I just scroll down and show you the endpoint, that's how the endpoint looks like. So if I take you to my Kubernetes cluster now, notice this. So we have, I hypothetically, I have kept three of them. So this is the maximum configuration which is there in my example. So what is happening inside the Kubernetes cluster is this is the pod which is there, and this is Docker container right now, that one, and my model is there, and entry script and dependencies, and three instances of that is right now running over there. 1, 2, 3. One service got created in Kubernetes, and when the API calls are coming in, the API calls are coming in, something like that, and the requests are going in. I have a more detailed diagram of this. This is not the detailed diagram, but this is just the overview of it, how the service will be used, and the service will be resolved throughout the cluster. Service is another component inside Kubernetes, which is resolved throughout the cluster. Now, the detailed diagram is over here, where you will notice that how the deployment happens inside Kubernetes. So if I zoom in into this one, you will notice that what happens is, I'll just use my various colors over here. So this is here we have the master node. The API server is there inside the master node. And right now, so as you know that in the master node, we have four components. We have API server, HCD is there, scheduler, and the controllers are there. So all of that is happening in that purple box on the top. Now, the bottom part represent your cluster, the nodes as such. You will notice that there are two services in this diagram. There are two services. I'll practically show you in my example. One is there. So, but there is one front end service which is called as Azure ML-FE front end. So this will be created by your machine learning service when you will do the deployment in Kubernetes. They will make that, right? So it is being represented over here. It will also scale out. That's why you can see more than one instance is there. But if I take you to my current Kubernetes cluster, and if I show you that part over there, you will notice that I just ran that query. So you will see that we are getting the services, and this is the one which is there, the FE. And let me see if I can zoom out slightly. Okay, so you will see that this is the front end service which Microsoft, or you can say the setup which we have done. That setup deployed this, and over there. Now, and if I show you this IP address 20.121.2236.8, this is the IP address which we also received 23.8 over here in the endpoint section. Now, how is the translation happening, or how is the traffic flowing? To understand the traffic flowing, we have to come back to this diagram. So you will notice that when you work with Azure Kubernetes services, they basically have these standard load balancers. They will be in your managed resource group over here. So the standard load balancer which you see is somewhere in the RG. So if I take you to the resource group, and if I take you to the managed resource group, this is the resource group which Kubernetes cluster creates for itself, and it maintains its own resources there. We don't make that. So all of these are AKS resources right now. And if I take you to the cluster, the load balancer over here, Kubernetes load balancer, you will notice that whatever we are able to see will be happening over here inside this. Now, one of them should be the front end for the machine learning service which we have deployed. We can click on one of them and see which one is the correct one. And I can see the IP address here, 121.238.8. So that is the IP as such. Yeah, over here. So if I take you back to my diagram, you will see that the request is basically hitting that, or the front end IP which we were seeing of that Azure ML-FE service is mapped with the load balancer, and the model which we are deploying, that model is running in a pod behind it over here somewhere like this. So if you go back to your Kubernetes cluster, you will be able to notice that as well, that if we say kubectl get pods, and I actually don't remember which namespace I created, so I will just get it from all the namespaces. So the namespace which I have over here is called as Azure ML hyphen Shivam's ML. That's my the model over there as such, and which in the diagram is basically this yellow icon as such. So if I, and these are the other things, the registries and so on and so forth. So if I just zoom out from it, the simplified diagram is how you see it over here, that the models are deployed inside the Kubernetes cluster, and there are some load balancers outside by which the ingress is happening right now, and the traffic basically hits uh, the models over there. So endpoints, they represent the REST endpoints, and the deployments will be having all the components which will do the deployment, like model, scoring file, environment, or the compute. Now there is something very interesting which they have done recently, which I can show you in the Azure portal. If I take you to my machine learning workspace, if I take you to any machine learning model, and if I click on any one of them, and if I click on deploy, you will notice that we have three options now. So if you're working with Azure ML since many years, you will remember that we used to have this one web service option over there. Now what they have done, they have created these. It's in preview right now, but you see this deploy to real-time endpoint preview. If I click on it, you will notice that it will ask me for this managed endpoint, like this, like managed. Kubernetes is the other one which I was showing you, but the other one is called as managed endpoint. So if I explain what is that managed endpoint, you will notice that I have a small uh, flow diagram which I took from internet. I actually copied it from one blog, but I by the time I pasted it, I closed the link, so I don't have the source of the person who made it. So all credits go to them. But if you notice this, so in when you talk about real-time inferencing, we have these two options: the managed endpoints and the self-managed ones, the Kubernetes endpoints. So which is okay, fine, you manage it, but the managed endpoints are managed by the cloud. So the patching behind the scenes, the scaling, it's like a turnkey solution. Like it's everything is ready-made over there. So if I go back and create that, so I'll zoom out first. I'll give it a name, managed endpoint for my model, and we leave it default. And that's the scikit-learn model. So let's leave it to that. Now it's asking for the deployment name. We'll leave it default. Deployment is that deployment. If you notice it over here, is this deployment over here. And we can have multiple deployments behind one endpoint, like just FYI. One endpoint can have multiple deployments, like in blue-green manner over there. So if I go back and if I just maybe we can enable the analytics. Not that's not the main purpose of this session, but scoring file. If you remember, the scoring file was a file which is mandatory, and it is supposed to be there in the deployment location. You see that red circle which we have, this one, scoring file. So we have to give that. I have it with me. I just saved it so I can upload it in this time. And which environment do I have to provide? So these environments are already uploaded, available from Microsoft, from this AML service. Otherwise, I have to provide it myself. So the environment, I will just see. It's supposed to be one scikit-learn environment. Okay, only one is there. So we'll select this scikit-learn environment. And next, now it is asking for how many virtual machines are going to be there. So that's what I was telling you about that. The uh, that the managed endpoints are basically, uh, you can see, I'll show you a couple of more details. I have it with me. So these are the possible options which are there. We can go for these sizes right now. GPU sizes are there, memory optimized sizes, compute optimized sizes. And memory optimized sizes will have more RAM, less CPU. This will have more CPU and so on and so forth. General purpose over there. So these are various sizes. So the machines will be there at the backend, which are dedicated just for the purpose uh, of deploying our or for hosting our machine learning model, and they will scale as well based on the need. So you don't have to have you don't have to manage Kubernetes to be able to host it. You simply have to work with this managed endpoints. So if we go back and if we do that, you will notice that we will be able to select some instances. I have two of the instances already running. I'm not sure if I will be able to select one more or not. It's giving me. some quota limit issue. I'll try to change it. Okay, great. So I'll go for one instance. I'll see if I can go for two. In my demo accounts, there will be slight restriction on the quota, but in your production accounts, you don't have any issue like that. So I'll go with one itself. And how much traffic do I want to take it to that one instance? I have one instance only. I'll take 100% traffic to it. But if you are doing any blue-green deployment, then you can specify how much traffic will be going to the first one versus the second one, and go for it, right? So it will take some time to deploy, but you will notice that this another endpoint will be coming over here, the third one, once it once it. Uh, I hope we saved it, so it will show up there in few minutes. So you will notice that the previous ones are already online. One is based on Kubernetes, one is based on container instances over here, and they are pretty happily running over there. And I would like to show you a couple of more things which I have for the session over here. Now, the real-time inferencing is what we are doing. And the other one is called as batch deployment. Batch deployment is the one where the you will be scoring a lot of data, but in batch mode on some schedule as such. So definitely that can also be done in Azure, but that topic is for another day. And I'll take you back to the I'll take you back to the code over there, and would like to show you a couple of more things over here. So this is how you do the deployment in Kubernetes. So this is like more production grade deployment, but definitely the cost of Kubernetes is pretty high as well, right? So if you have high application density, then you can justify the cost. Otherwise, you will be it is way cheaper to run things in the endpoints and the deployments, the new ones, the new options which we have. It will be way cheaper in that one because this cluster will be pretty pretty extreme over here. Now, if you don't want to use Kubernetes and in the testing environments, it doesn't make sense to do that. We also have the option of simply using the ACI. So just FYI, ACI are the container instances, which they if somebody asks you like what is the easiest way of running your containers in the cloud, you can run them in ACI. You can just run your containerized solutions there. So we are and it's as simple as this. So we have this one container instance right now where, and if I take you back to my resource group, I will be able to show you that we have it running in this one, diabetic service ACI, that one, and the container is running over here. So the model is deploying here. So this is just to show you that we can do deployments in all the different type of solutions in the cloud over there. And now, so let me just go through the questions as such, uh, and I'll just ask you for your questions. And this is how we do the deployments, or these are things which we manage as part of the real-time inferencing. And before I do that, I want to show you something very interesting. The score script I didn't showed you before. So this is the score file. So the score file is the one which is supposed to be in your production environment, or it is supposed to be there in the model, this one, in the image over there, or in the container. That's the entry script, this one. So how does that look like, right? So it is going to have two functions over there, initialization and run. These two are minimum required. Now initialization is going to do the initialization of the model. Now it can be loading the model which is locally present. Sometimes what we do, we load the model directly from the model registry also during the initialization step. And then the run function, this is the one which will get the data from the input API call, and will do the model.predict. We can beautify the output, and then we can return the output back. So the this if it, and just to see how does it look like when it runs. We are doing the scoring against the Kubernetes endpoint right now. And this is the scoring endpoint. That's the key right now for my API call. That's three data points which we are doing the scoring against. And we are using diabetic data set. And you will notice that we are getting the output labels over here, diabetic, non-diabetic, non-diabetic, like this. So So how it worked? The score script basically initialized the model and did the model.predict and throw the output back. Okay, so there are some questions in the chat. What are the alternatives to ACI Kubernetes if you want to save the cost? Now, the save the cost is the new one. Kubernetes will be way, you can say, if your company is already having Kubernetes cluster, it may make sense. Otherwise, it will be very expensive to run it over there. So the new options which we have about of the managed instances where the VMs are dedicated for that purpose, that's one definite way of running it over there. Otherwise, the images can be can run anywhere. Like if you have this image, you can also run this in app services, Azure app services, and uh, you can also, you can say, uh, run it maybe as part of any VM, which is anyways covered as part of managed endpoints, or download it, run it locally. So these will be the options. The best option will be the managed endpoint versus AKS. Okay, so guys, now I'll just ask you for your questions, and whatever we have discussed is also available on the learning module link over here. So I'll just give this link again in the chat in case you want to bookmark it. And whatever we have discussed, you can as well uh, do it practically after the session also, right? So let me read your questions. Go ahead with it. Right? Okay. So how much time does it take for auto scaling? Now the default setting will be evaluated every 30 seconds. So the auto scaling will get triggered in 30 seconds. You can change the time as well. You can specify we scale out fast, we scale in slow. You can specify the times as well for the auto scaler. And if we think about pod-based autoscaling inside Kubernetes, it will happen in milliseconds or seconds. But if you think about VM-based autoscaling, it will take some practical 2 minutes at least, right? 1.5 to 2 minutes should take, because the VMs generally take that much time for scaling out. What is the advantage of using ACI over the Docker images over VMs? Okay, the advantages of this Azure Container Instances will be that it's a total managed solution. There is, for example, if I create my own VM, uh, let's say, okay, let me add one more point over there. Just want to be on the, let me just clear that thing. So let's say this is some standalone single VM, which we are not considering much, but we are thinking of going for the managed endpoints. The the managed endpoints will be a set of virtual machines which will scale out when required as such, and you will which will also ensure that we have high availability, and we can definitely go for like doing it manually as well, but we have to do the patching here. Let's say patch here, the patching has been taken care of. Patching has been taken care of. So in the managed endpoints, there is no patching which is required. It is managed by the cloud, scale out, scale in, and in ACI, here also the patching is taken by the cloud, but auto scaling is not there. So it's not going to help you in that section. This is going to auto scale over here. And I have a nice differentiation with me, and I'll just walk you through this nice differentiation over here. So we have the managed endpoints. So let's have a look at that. So it's recommended users will be the users who want a managed model deployment for the enhanced MLOps experience. For the Kubernetes endpoint, the people who want to do self-management will use it. The managed endpoint will provide you with scaling, operating system image updates, and security hardening. Everything will be managed by them. In Kubernetes-based management, or we are responsible for it. We'll do the hardening ourselves. We'll scan the images for vulnerabilities. It will be on us. The compute type is totally managed. Here it's Kubernetes. Uh, the monitoring is available with the help of Azure Monitor. Here we have some monitoring available, which we can enable. So, but rest is unsupported. The logging will be done by Azure logging as such. It's possible there as well. Now it's sort of on the equal level. Application Insight is supported in both of them. Managed identities are also possible. Virtual network integration, they are still working on it here. It's already inside the virtual network. So this is very suitable. They are working on this part over here. It's absolutely required for production. But the service is in preview, so we have to wait for it. But from the point of view of cost, the cost is from endpoint and deployment. And here the cost of the entire cluster, which is on the higher side. Right? Think about it. Okay, so uh, go through your, let me know your questions, guys. And okay, and don't forget to join us tomorrow as well. We have a session tomorrow on data science and data science with the data which we are getting from NASA. So it's publicly available. We just took that data, and we'll talk about Azure Machine Learning with interesting space rocket launch data which we have gathered from NASA. You can please join us for the join us on the YouTube page, join us on the LinkedIn group as well, join us on the Meetup page, and you can find the recordings on YouTube. And we do a lot of sessions very regularly. This is my, I think, 30th session, it seems. So you can find the previous ones, and there are a lot more to come, right?
I think we have a question from Girish. So Girish, if you join the meetup group, you'll be able to, find tomorrow's session, and you just have to, RSVP for tomorrow's session, and then you get the joining link. So if you're on meetup, then probably you will know for tomorrow's session as well.
Join the Meetup group so you can get the links for all the sessions which are happening, right? And not just tomorrow's session. So please do that.
Okay, so if we don't have any more questions, then we can wrap up for today. You can always reach out to Shivam. You'll find his social handles on the meetup page. Thank you, Shivam, for the session, and thank you all for joining us today. Please do share your feedback about today's session, and please use the Learn module link shared in the chat section. This will give you access to additional resources to take your learning further. Thank you once again, and enjoy the rest of your day.
Thank you, Rashmita. Thanks, everyone.
Thank
I
you.